now reading 23 hours, 12 minutes, indicating that we're now less than a day away from that time that the Apollo 8 spacecraft starts its pass over the backside of the moon and out of communications range with Mission Control Center. It's relatively quiet here in the Mission Control Center now. However, we don't expect this to be representative of what it'll be like in this room this time tomorrow. At 45 hours, 45 minutes, 40 seconds into the flight, Apollo 8. This is Apollo Control, Houston.
Apollo 8, Houston.
Go ahead, Houston.
Jim, when you get a chance, either you or Bill, would you give us a crew status report on you and Bill?
Roger. We're going to finish up this one set of Star 40, then we'll do that.
Okay.
Okay. Have you been getting this data down there in Houston?
That's affirmative, Apollo 8. Jim, so far we've only missed 1 point. We'll ask you to read it back a little bit later.
Which one do you need?
Stand by. Apollo 8, Houston, what we need is the third mark on the first set, star 33, trunnion only. Over.
Roger, that's the only one we're in data. We think it was 12020.
Roger, copy.
Okay, that completes 23 for this time, Houston. You satisfied?
Roger, Jim.
Houston, for information, the last two stars, 34 and 40, were shot at the very tip of the thin rim. And you practically have to imagine the rim continuing on past where it goes into darkness.
Roger, I understand they were shot at the tip of the lit rim.
That's affirmative, and the area around the entire moon now, both the sky and the moon itself, are all milky white because of the nearness of the sun.
Roger, copy. Apollo 8, Houston, you can reestablish PTC, same attitude, 224 and 20.
Roger, Houston, I'm heading that way now.
Okay.
This is Apollo Control, Houston, at 45 hours, 58 minutes, 20 seconds. Now into the flight, Apollo 8. We read Apollo 8's altitude at this time at 156,917.4 nautical miles. The velocity reading shows 3,673.5 feet per second. Jim Lovell has completed his program 23 navigation sightings, and at this time the Apollo 8 spacecraft is being returned to a passive thermal control attitude. we'll play the report that command module pilot Lovell passed down to our capsule communicator Jerry Carnell.
Apollo 8, Houston.
Go ahead, Houston.
We'd like to have you start your wastewater dump. We'd like to have you start your wastewater dump as soon as you can. Dump to 20%. We're doing this in order to get 71% at LOI. Over.
Understand, 20%.
Roger.
Apollo Control, Houston. We picked up the last transmission as it was going on. The advisory that Apollo 8 should proceed with its wastewater dump as soon as possible. And so at 46 hours, 3 minutes, 3 seconds into the flight, Apollo 8, this is Apollo Control, Houston.
Apollo 8, Houston.
Go ahead, Houston.
Roger, we see the wastewater coming down now. While it's on its way down, how about a cryo fan cycle?
Okay, cryo fan cycle. I'll cycle H2 and O2 fans one at a time, 2 minutes each.
Roger. Apollo 8, Houston, we're showing you at 20.0% now.
Roger, we're showing about 25. We'll shut it off now.
Roger, next on deck is the fuel cell H2O2 purge.
Stand by.
This is Apollo Control, Houston, at 46 hours, 25 minutes, 22 seconds, now into the flight Apollo 8. We now read an altitude of 157,868.9 nautical miles for Apollo 8. Velocity now reading 3,651.2 feet per second. The wastewater dump has been completed by the Apollo 8 crew. And here's a conversation regarding that sequence. So that's it. At 46 hours, 27 minutes, 10 seconds into the flight, this is Apollo Control, Houston.
Okay, Houston, we're ready to start the purge.
Roger, Bill. While you're purging, can you give us a crew status report?
That's going to be O2 and H2, is that correct?
Affirmative.
Roger, H2 first, okay?
Roger, that's okay.
We're getting H2 flow, Jerry, but we don't see any vapor particles anywhere. Summer starting now.
Roger, we confirm your flow and understand you're seeing particles now.
Yeah, not much though. Okay, gonna go on number 2.
Roger.
You know, it's really too bad these side windows are fogged up because we never see the sun in the rendezvous windows and we can't get very good pictures through these foggy ones.
Roger, that's a shame.
Okay, start number 302.
Roger, Apollo 8. Apollo 8, this is Houston. Would you set for accept for a P27 update, state vector to your LEM side, and we would like you... Roger, Bill. Would you set up to accept a state vector update? We'll be putting it in the LEM slot, and do not unzap, over.
Roger. Roger, normal accept. I'm going to put the word zap back in the dictionary.
Roger, Batman.
Houston, Apollo 8.
Apollo 8, Houston, go.
Might be interesting to note that after nav sightings, we ran out P21 and we get a pericentia now of 66.8 miles.
Roger, 8, we copy.
I knew if he did it long enough, he'd finally get one that was close. Okay, start fuel cell 2.
Roger. Apollo 8, Houston, your state vector update is complete and verified. You can have the computer back and block, over.
Roger.
This is Apollo Control, Houston, at 46 hours, 40 minutes, 20 seconds now into the flight of Apollo 8. Present altitude, 158,396.4 nautical miles. Present velocity, 3639 feet per second. 3,639 feet per second. As we pick up this conversation, we find the crew undergoing one of the systems procedures, that of a fuel cell purge. Let's pick up that conversation.
Okay, go to number 1, mode 2.
Roger, Bill.
Oh, the helmet canal's kitchen timer's pretty nice.
Roger, Bill. You can turn off your H2 heaters now.
Look up.
Bill, we show you 168,000 out, and we're still getting pretty good high bit rate off the 30-foot dishes.
Okay, I'm in narrow beam, high gain now. Were you getting a good high bit rate on the Omnis?
That's affirmative. We're back on high gain now.
Okay, number 102 is off, and you clarify your previous statement. Were you getting good high bit rate while we were on the Omnis about 10 minutes ago? Over?
Apollo 8, Houston, that's affirmative. We were getting fairly good high bit rate with a little bit of noise.
Okay, good deal.
Roger, we only got 2 things left to do now. We need your crew status report and a redundant components check.
Jim will give you the ladder, former, and I'll give you the ladder.
Okay.
Apollo Control, Houston. As you heard, we sent a load to the onboard computer to update the state vector. This was sent and verified. Also, that was Jim Lovell along with the
Bill
letters.
Econ says
Jim
thanks for the
indicating
good job of keeping the Omnis moving.
they had narrowed their paracynthian through additional nav sightings down to 66.8 nautical miles. Bill Anders obviously in very good spirits, as you heard through the course of that conversation. At 46 hours, 45 minutes, 5 seconds into the flight, this is Apollo Control, Houston.
Who's on the watch with you?
It's just me right now.
What Econ?
Oh, we have Clint. The Black Watch is watching.
Alert.
Roger, the Black Watch is watching.
Roger, I'll stay up. Roger, I'll stay alert. Okay, Houston, here comes the status report.
Roger, we're ready to copy.
For sleep. Roger, for sleep, each of us has had 2 sleep periods. Frank's in his 3rd one right now. Bill's had 6 hours the last time. I had 4 hours the last time. Good to fair, both of us. Frank had 5 hours the last time of fair. And Frank, of course, is sleeping now.
Roger, Jim, how are the 3 of you feeling?
Water. We're all feeling pretty good now. No problems. We've all had about between 40 and 60 ounces of, or clicks of water so far today.
Okay.
On the food, we're up to, or we've eaten day 2, meal 2 so far. And most of us have eaten the rehydratables and the juices and about half of the solids.
Roger, copy.
The cabin's running slightly cold. We do have one cabin fan on, and we're in full heat, and it's running just slightly under 70. Might be a design note for a future spacecraft.
Roger, Jim, is that fan pretty noisy?
It's not as noisy as both fans when they're running. We cut it down to one fan.
Roger, we keep thinking we hear it when you're talking to us.
I would be a bit surprised. Houston, we're showing a glycol evap temp around 44 and a rad out temp of about 28. I wonder if we might try some manual mixing here to raise the glycol evap temp out a little bit.
Roger, Bill, stand by.
This is Apollo Control, Houston, at 46 hours, 53 minutes, 58 seconds into the flight. Our current altitude on Apollo 8 is 158,873.2 nautical miles. Current velocity...
Okay,
3,627.9 feet per second.
Roger, Bill.
We've received a status report from the crew, and we'll pass this along now.
Okay, we're boiling the secondary evap, and temperature stabilized, and so we're going to close up the back pressure valve.
Roger, copy. Apollo 8, Houston.
Go ahead, Houston.
Roger, Bill. Before you try the manual mixing, we'd like you to give a whirl at the manual and increase on a cabin temp. Over.
We've done that. We're in full hot. And what's the lowest individual rad out temp you've seen here during our peak DC?
Roger, stand by. Apollo 8, this is Houston. We saw 26 one time.
Roger, understand. Plus 26.
Affirmative. Apollo 8, Houston, go ahead with your manual mixing. Suggest you set your evap out at about 55, over.
Okay, we'll give that a try and let us know if the rad out temps get too low.
Roger, we're monitoring.
Apollo Control, Houston. We now read ground elapsed time of 47 hours. Perhaps it's good to point out again that as we examine the data in the early hours of this morning, we chose not to do the mid-course correction burn at ground elapsed time of 47 hours. The reason we chose not to do this, the data indicated that the burn would be in the magnitude of about 1 foot per second. This would be followed by a water dump, which would have some perturbations on the trajectory, and it appeared wise to pass this one by. So at 47 hours, 1 minute now, this is Apollo Control, Houston.
Houston, Apollo 8.
Apollo 8, Houston, go.
All right, we have it stabilized about 53 degrees, and we'll leave it there, but we'll go back to auto if you start having any concern about the radiators.
Roger, Bill, we're showing 51.4 here.
Okay.
Apollo 8, this is Houston. We're going to have a command change over to Honeysuckle in about 2 minutes, over.
Roger, Houston, standing by.
Apollo 8, Houston, that was Honeysuckle to Madrid.
Si, senor.
Goodbye, you chaps.
Houston, Apollo 8.
Apollo 8, Houston, go.
Roger, did you delete the cislunar nav exercise at 47:15?
That's affirmative, and we added the extra star settings to the one at 45.
This is Apollo Control, Houston, at 47 hours, 25 minutes. Now into the flight of Apollo 8. Apollo 8 now showing a velocity of 3,603.1 feet per second. Current altitude just under 160,000 nautical miles, 159,968.9 nautical miles. We have a short strip of conversation with the crew, and we'll play that now. Apollo Control, Houston. That concludes our latest conversation with the crew. At the present time in Mission Control Center, some members of the green team are beginning to arrive. We will have a change of shift within the next hour. And during the green team's time aboard, we will cross that great divide in space at 55 hours, 30 minutes,
Apollo 8,
about
this
8
is Houston.
hours from
Buenos
now,
dias, muchachos.
where for the first time in a manned space flight, the Earth's sphere of influence will be secondary to another celestial body. Apollo 8 will enter the moon's sphere at about 55 hours or 30 minutes. At this time, the attraction of the moon becomes greater than the attraction of the Earth.
Okay.
Our display references here in Mission Control also have the capability of following suit. We'll probably show such things as altitude and velocity relative to the moon. At 47 hours, 28 minutes, 25 seconds into the flight, this is Apollo Control, Houston.
Houston, Apollo 8.
Apollo 8, Houston, go. Apollo 8, Houston, go.
Roger, my two cohorts are going to try to get some sleep here, so y'all might keep a good eye on the systems. I'm going to move on the other side.
Roger. Apollo 8, Houston, we're getting low bit rate now. We could do better with a high gain antenna before you move over to the other side, over.
Houston, Apollo 8.
Apollo 8, Houston, go.
Roger, you might just give me a call every now and then, Jerry, to just let me know you're still there, or as we're switching antennas, or play some music or something.
Say again, Bill, you're kind of garbled.
I say you might just give me a call every now and then as we switch antennas. Just let me know you're still there, or play some music or something. Just make sure we haven't lost comm.
Okay, Bill. Your antennas are looking good now. Hey, Bill, if you want music, I'll have Mike sing.
Let's get the sing anchors away, will you?
This is Apollo Control, Houston, at 47 hours, 43 minutes, 53 seconds into the flight of Apollo 8. Our current altitude reading, 160,614 nautical miles. Current velocity in feet per second, 3,588 feet per second. We've had additional conversation with the crew, and we'll pass that along now. So this is Apollo Control, Houston. You no doubt gleaned that last comment when Jerry Carr offered a musical rendition by the oncoming Capcom, Mike Collins. Mike just walked into the room a few moments ago. He will take over duties as a capsule communicator shortly. So at 47 hours, 46 minutes, 50 seconds into the flight of Apollo 8, This is Apollo Control, Houston.
Apollo 8, Houston. On your secondary coolant loop, looks like your back pressure valve might be slightly open. Suggest you go to secondary coolant loop evap, switch to the reset position for 58 seconds, over.
I did that again. I'll try it a third time.
Okay.
That didn't do any good, Houston.
Roger, Bell.
Keep an eye on it, see if it starts dropping. It stabilized there right after I shut the evaporator off.
Roger, we're watching.
What might have happened, Jim might have gotten the water control valve off before he completely had the back pressure valve closed.
Roger, understand, Jim. Turn the water control valve off.
All right, we have the secondary water evap control valve off, and he might have gotten it off on that return temperature check prior to the time the evaporator back pressure valve had completely closed, which might explain the lower than nominal steam pressure.
Roger, understand.
And this is Apollo Control, Houston, 48 hours, 30 minutes into the flight. The green team, the green launch team has come to work here in the control center, and Flight Director Cliff Charlesworth has gone around the room, console to console, getting a status report. The only little minor problem we've uncovered here,
Bill, we see your secondary steam pressure coming back up slowly, and we'd like to just sit and watch it for a while before doing anything else.
Suspicion cast at the secondary coolant loop. It may not be closing properly, and a procedure was passed to the crew to take a look at that. All else seems to be quite normal. We have some brief conversation backed up, and we'll play that for you now.
I get the idea.
And this is Apollo Control, Houston. We're standing by, or estimating right now, a press conference from the previous shift should begin a change of shift briefing in approximately 8 minutes, shooting for 7:30 Houston time. We want to alert all press people to that fact. While that tape was playing, we did hear an analysis from the surgeon's console here, and they said while they felt the crew was doing better with their little medical problems of yesterday, they didn't feel like they were completely out of the woods yet. They note that they are behind on water, and they're apparently behind on sleep. They're also not eating as much as they planned. But generally, they're pleased, and the situation is an improvement over yesterday morning. At 48 hours, 33 minutes, and 162,320 miles from Earth, this is Apollo Control, Houston.
Huh? Okay, it appears that we haven't filled the stadium, but we're going to start anyway. I believe all of you gentlemen here know Glynn Lunney, the flight director of the black team.
Good morning.
It's a pleasure to be here this morning. It's my first time over for a conference
on this flight. I guess before I start the debriefing, I'd like to say personally that I am real pleased, and so are the rest of the men over in the control center, about how things are going so far. Spacecraft seems to be performing in essentially perfect fashion. The mission seems to be going overall in a very nominal fashion. The trajectory is well defined, and the approach to the moon at this point seems to be well defined. Of course, we'll be working on that problem all day, getting the tracking data in from around the world to improve our knowledge of what's going to happen when we get to the moon. We're anticipating one more mid-course before we get to the moon, and I'll talk about that in a minute. The crew sounds real good this morning. There has been some difficulty. They've had some trouble. However, they seem to be pretty chipper this morning. As a matter of fact, Bill Anders sounded just like he does in some of the simulations that we've been running prior to the flight. I think that the men who are up have been kind of quiet on the loop, partially because they're trying not to talk too much with the other guys trying to go to sleep. Just before I left the control center, Bill Anders indicated that he would not talk too much for another little while the commander, Frank Borman, was in a sleep period. Okay, with those general remarks, my team came on duty last night at 39 hours elapsed, about 10 o'clock here, I guess 11 o'clock, yeah, 10 o'clock here in Houston. At that time, we were about 142,000 miles from Earth. We were at an inertial velocity of about 4,000 feet a second. When we came on, both the command module pilot and the lunar module pilot were asleep, as they were at the end of the previous shift. Things were fairly quiet. There was some small conversation back and forth between the control center and the commander. We give him a news broadcast and things like that. Perhaps as an indicator of looking ahead in the flight, Frank Borman asked for a weather forecast for the 165 recovery area out in the Pacific, which we gave to him. That's still pretty much of a long-range prognosis, though, more than anything else, and is based on the seasonal conditions we have out there in the Pacific. The commander at about 43 hours discussed the fact that the cabin was cooling off some. It has been cooling off slowly over the course of the flight, and it was down to 60 degrees. There are just a few things that can be done about this, and we tried to, with just one man in the cabin, to do the only thing we could, which was to crank up the thing to full hot and turn one of the fans on. We're generally reluctant to have the fans on because of the noise that the fans provide. It's not really a bad noise, but it's some amount of distraction when people are trying to sleep. And perhaps recently on the air-to-ground, you've been able to hear the hum in the background. That's probably due to the cabin fans, we figure. At about 43 hours this morning, the command module pilot woke up. We took our tracking data up to 42 and a half hours, at which time we terminated the track and did an update to obtain a vector on it. Based on that information, we had a mid-course 3 of approximately 1.1 feet per second. If we decide, as we did, not to do that maneuver, at the present time we're predicting a mid-course 4 of about 3.3 feet per second. A couple of reasons for not doing the maneuver this morning, the mid-course maneuver. One is that it was small enough to be almost at the level that you're not sure whether that's the mid-course or whether that's just the uncertainty in the orbit definition or the trajectory definition at this point. We have a 1 foot per second threshold for doing any kind of a mid-course. Secondly, we're going to be performing a water dump in order to get the wastewater dumped down now so that it would fill back up and be just about at 70 to 75%, which is the kind of water load we want in a waste tank going into lunar orbit. And with the star sightings that we had scheduled, we were planning to do the waste dump at a time which effectively would have been after the mid-course. And the wastewater dump itself, as small a force as that is, tends to disturb things. So we elected not to do the mid-course 3 this morning. Command module pilot joined us then, and Frank Borman, the commander, went below to catch a couple hours. We passed up some block data. Jim Lovell started the realignment work, Program 52, which is realigning the inertial platform based on taking some more star measurements. He then moved into some star sighting and navigation work. What was going on this morning is that for the first time on the way out, we started to make observations and measurements of star angles to the lunar surface. Up until this time, we had been making them star angles to the Earth horizon. We found that the definition of the knowledge of the orbit in the computer was being updated properly as we were making the Earth horizon sightings. And we felt we had all the data and all the accuracy that we were going to get from those. And at the geometry we are at, or as you can see on the map, most of the way to the moon, we were starting to get more strength or more accuracy in the solution by taking measurements on the lunar horizon and the stars. That went on for a while. You've heard discussion, I think, over the whole period of the flight, as we did on Apollo 7, about the qualitative remarks that the pilots are making, and they try to give us a feeling and an understanding for when they're able to see the stars and when the sun kind of gets in the field of view and they're not able to see them. And I think all that sometimes perhaps may mislead you in that the accuracy that we're getting with the onboard navigation system in this, its first application out there in that environment, is really very good as far as we can tell. For example, after the last set of star lunar horizon marks, during the course of which Jim Lovell had trouble with one star because the sun got close to the field of view. However, with those sightings, the command module pilot with the computer on board was able to predict the paraloon, or the lowest altitude he will have up as he goes by the moon. The number he got this morning, I think, was 66 miles, which is within just a few miles of the latest prediction that we are getting from the Worldwide Tracking Network, that number being about 70 at this time. And for this geometry and for these systems, that is an excellent agreement at this time in the paraloon. There is more work going on to more fully evaluate the navigation that is now available on board, but as an indicator of how well that's being done, a couple of miles in altitude at the moon is a real good number to have at this time. We went back into the passive thermal control mode at that time. As I said, we had deleted the mid-course 3, which was nominally scheduled for 47 hours. We had some amount of work to do. Bill Anders came on the loop at about 45 hours elapsed, and we had a couple of pieces of work to do in his specialty area on the right seat. As I talked about, we arranged to dump the wastewater. We caught the fuel cells up with a purge, and we cycled the fans in the cryogenic oxygen hydrogen system. Fuel cell purge I talked about, and we did a redundant components check in the ECS system, checking the secondary coolant loop. That went pretty well, although there's some work going on right now in that it appears that perhaps the back pressure valve did not close completely in the secondary evaporator, and that's being troubleshot right now. I don't think that's anything serious, but also I don't know all what's going on in the control center on it right now. That was about the extent of the work. As I left at 48 hours, we were at an altitude above the Earth of about 160,000 miles. As I said, the paraloon that we were predicting from the network tracking was 70 miles. For the next couple hours, I don't think you'll see too much activity. It's primarily eating and sleep period. There'll be some more star angle to lunar horizon work in the early 50s elapsed time, in the 51, 52, 53 period. There'll be some more of that work in order to, again, determine how well we can navigate on board and to keep that vector on board the spacecraft computer. During the rest of the day, there'll probably be another sleep period, and then the preparations will start tonight for the LOI burn. At the present time, everything in the spacecraft mission and people looks good for the lunar orbit, and we're looking forward to doing it tonight. As a matter of fact, my team will be on tonight when we hope to do the lunar orbit burn. Give you a little feeling for the consumable status. As you know, we're slightly down. We were down some in the service module RCS at the beginning of the mission because of the extra maneuver that was performed in order to provide the separation. However, at the present time, we're probably using less fuel for the passive thermal control and navigation work than we had anticipated pre-flight. So we're probably just beginning to do a little bit better, and we're beginning to narrow the gap rather than having anything increase. I would like also to point out to you that the margin we have for the end of the flight is still considerable, and if we were to continue to perform all the activity that we have scheduled at the rate of fuel expenditure which we're now having, we would end up with about 600 pounds left at the end of the flight. In the cryogenic area, we are well up on oxygen and hydrogen. As a matter of fact, we could complete the mission on one oxygen tank of the two, which are now still working fine. And at about 60 hours into the flight, we would be able to complete the flight even on one hydrogen tank of the two, which are now working fine. So in that area, again, the consumables are in good shape, and in general, we are still in the posture that we are comfortable in that area as we were when we took off, and we still have good margins in both of those areas. I guess that about summarizes what I have for you by way of the shift briefing and what's coming up today and where we are in consumables, and I guess it's time for questions.
Would failure of the secondary coolant loop compromise the mission in any way?
Well, for failure of the entire loop, that is to say, we would not be, if we were not able to get any coolant out of that loop, I think we would perhaps not go into lunar orbit. However, the indication I discussed earlier is in no way any kind of an indicator of that, Art. Apparently, and I don't have all the data on this as it was just happening as I left. Apparently, they weren't satisfied that the back pressure control valve, same as in the primary evaporator, had closed completely, and they were in the process of troubleshooting that.
Is the latest status on both the crew and the spacecraft that you definitely are going for LOI?
Yes.
And also, did I gather right that you are not planning between now and LOI to use SPS?
That is correct. The mid-course that now appears to be necessary at the mid-course 4 point is on the order of 3 feet per second, which we would not do with the SPS engine.
You've skipped both 2 and 3?
Yes. Both 2 and 3 were essentially unnecessary.
I got in late, Glenn, and if this has been covered, forget it. I'll pick it up from someone else. But what about a medical status report on each of the 3 men? Okay.
That would be fair to do anyway. Last night the men discussed the general status of the crew, and Dr. Ziegel-Schmidt was over to talk about it. In the previous 8 hours, there has essentially been mostly a sleep period. All of the men have gotten on the order of 6, 4, or 5 hours sleep in the last 8. In asking Jim Lovell about it this morning, there were no reports of any additional medication taken in the last 8 hours. Jim's comment was that they were feeling fine at this time, and they didn't have any troubles. I made a subjective remark at the beginning that I felt that Bill Anders this morning sounded just like he does in the simulations. And I also made the point that probably when we have 1 or 2 guys sleeping, the other guys tend not to prolong conversations or chat because that kind of disturbs the other guy, and we'll see some of that today still, I think. Okay?
Let's see. Let's catch Mr. Pitt.
Do you know if they've been able to come up with some fix for the television so they can't show the Earth?
Well, First off, I guess as an indicator of the fact that the spacecraft is working well, we've had quite a few people working on the telephoto lens problem, if we can call it that. And there are a number of things we will try today. We will have some filters available from the other camera equipment, which we have been working on overnight as to what filters to use depending on what the signal looks like to us in the control center. We also are going to be sure that the camera is allowed, the lens is allowed to look at the target for some amount of time in excess of 8 seconds in order to give it time for the thing to focus properly and set the light properly for itself. We're also going to remind the pilots to hold the camera as steady as possible. Personally, I don't know whether all those things will now make the telephoto lens picture come out right, but that is the class of thing that we're going to try to do this afternoon.
There's nothing they can do as far as adjusting the camera.
No, there's not much they can do, and of course the thing adjusts itself automatically. So it's mostly giving it time to work, plus taping these filters on the front end, and then using different filters depending on how the picture looks.
And is the mid-course correction 4, is that going to be at the scheduled time?
Say again?
The 4th mid-course correction, or the next one? That
Yes.
will be at
Yes.
6 hours.
61 hours elapsed.
Glynn, how are the windows? There were, during the night, there was some comment about maybe frost, or it looked like it might be frost on the outside
Yes.
of them.
Yes. The windows in general, I think, are the same as they were yesterday. The best viewing is out the two forward-looking windows, number 2 and number 4, what are called the rendezvous windows because they look forward. The center hatch window is apparently not very usable at all. Jim Lovell said this morning that it looked like, at different lighting, that it almost like it had a coat of ice or a coat of frost over. I imagine much like your windshield has in the morning when there's been a frost. And the two side windows still seem to be foggy and not as usable or as good for photography or sightings as the two forward-looking windows, the rendezvous windows.
On this same line, is the fogging bad enough to affect the photography, or have they made any comments?
Is the what?
The fogging of the windows bad enough to affect the photography around the moon?
It affects the photography, of course, out those windows. The photography in lunar orbit has been primarily designed to go out the number 2 and number 4 window, and I don't anticipate that will be jeopardized at all. Some of the other photography that we would be able to get out of the other windows we would probably lose, but the mapping kind of thing and the stereo mapping and that stuff is going to be taken out the forward-looking windows.
Have there been any more tape dumps involving one-way voice to the ground since the Madrid reception of approximately 25 hours GET, I think it was?
Well, Art, there have been dumps all along. I think what you're asking is, have there been any major reports or anything other than just debriefing, which is what's usually on that tape? And the answer is no. What's come down on the tape has been the standard debriefing stuff. As a matter of fact, we don't usually copy that stuff or listen to it except to see that it's okay in quality.
Okay. Are you getting it into mission control faster than the first one?
I think so. As a matter of fact, they were running a test over there as I was leaving, asking a site to find a place on the tape and play it in, etc. And that's mostly a matter of procedural things like getting people to the right place on tape and the right equipment hooked up, etc.
The figures 66 and 69 that you gave earlier, is that statute or nautical?
Nautical.
What is your latest estimated time for LOI?
Assuming that we do the mid-course of about 3.3 feet per second. I can't find my page. 690805.
What distance from Earth will you be at that point? Do you have that available?
No, I don't. I guess about 215,000 miles thereabouts.
Thank you.
A question I've been trying to get an answer to all night. Can anybody offer me some way of describing what is 320 lumens? I mean, is that like looking at a 60-watt light bulb from 10 feet away or something like that?
I can't. There's probably a physics book around the center somewhere, but I can't do that here.
I think Art Hill was asking what I'm trying to clarify. Have there been any private conversations that just took place before? Oh.
No, sir. No to both.
How soon before LOI do you expect to reach an LOI go decision? When do you have to decide?
Okay. We give a formal go to the flight crew at 68 hours elapsed, approximately an hour before. However, also as you know, a go for LOI is really being done continuously right now, in effect, and will be done right up until the time we lose acquisition with the crew. Plus, as they go behind the moon, of course, the flight crew has the same kind of rules as we do as to what they would call a no-go and not do an LOI burn for. So that is, there is a formal one, but it is essentially a continuous process.
Is that timeline at the bottom of the display now that says LOS and is counting down, is that the loss of signal on the first time behind the moon?
Yes, it is.
Any further questions?
Can you give me some kind of simple explanation about the sudden jump in speed and velocity when we switch from Earth's gravitational field control to the moon's gravitational field?
I guess it's a little bit like when we're sitting in the room, we don't have any velocity relative to the Earth, right? We're just sitting on it. But if someone were to say how fast are we going relative to the sun, we do have a velocity around the sun, okay? So it's just a matter of where you reference your measurements from, okay? The vehicle will, relative to the moon, have a different velocity than it does relative to the Earth, okay?
I'm just trying to check how this LOI procedure is going to work in terms of loss of communication. When you give the go-ahead at 68-hour elapsed time, am I right in figuring that you will have an additional 30 minutes of communication with
Yes.
the crew, and then 45 minutes you lose them? So you'll be 15 minutes after LOI before you find out, confirm LOI. Is that right?
I lost track of some of your numbers, perhaps. Let me go through it. Maybe I can help you. At 68, we will give them the...
We're in relation to the moon. Are they still the front side at 68?
Yes, and that's about 50-some minutes before they go behind, okay? So about 50-some minutes before they go behind, we make it a point to have a formal go, no-go, although this process is going on continuously. The reason for having it that early is to allow time to do all the other routine things that have to be done, the communications, the pad data that has to be read up, etc., as they go behind the moon. Also, it leaves the communication loop free for any other communication that wants to go on about what's happening. As they go behind the moon, then the burn will occur at about 69:08. So it really occurs about 10 or 15 minutes thereabouts after we lose communications with them. And then we would have communications. I think on this particular burn that we are only out of communications for about 35 to 40 minutes, not the usual 45, because for the first half of the way behind there, he's going faster than he is when he gets in lunar orbit, okay?
So you'll get, 15 or 20 minutes after LOI, you'll get them back in communication?
Oh, no, we won't get them until, let me see. Yes, approximately that after LOI.
If you get an LOI-1 that's satisfactory, would there be any conceivable situation in which you wouldn't go for LOI-2?
Yes, there could be such conditions. We have a number of spacecraft conditions under which we would, for example, not want to stay in lunar orbit. We would want to do the burn and come out. And were we to find when the flight crew comes around on the first or second pass that something like that had occurred, we would not bother with the LOI-2 and immediately begin preparations for a trans-Earth injection.
Just as a for instance, what would one of those conditions be?
Well, if we had, for example, a major electrical problem on board, or a major life support system problem on board, that kind of thing, maybe a primary coolant loop, for example.
Glynn, I know it's a continuing process, but can you help us use some intermediate figure here, a point at which in nautical miles from the Earth possibly, that we can say that they're in stronger pull of gravity from the Moon than from the Earth?
Yes. At about 55 hours and 38 minutes, I think exactly, we have at times said 30 minutes, but more exactly 38 minutes, you're going to be more under the influence of the Moon. That's going to be at about 176,000, as I recall, from the Earth, and about 34,000 from the Moon. Okay?
Any further questions? Okay.
Last night, Dr. Ziegelschmidt said the incubation period for this intestinal bug is about 72 hours. Now, if Lovell and Anders' first exposure to that bug was when Borman got it, that would mean that if they were going to come down with it, it might be at the time you're planning to do the TEI. Would there be any particular objection if they became ill at that point for extending the time going around the Moon?
I think the cases for which we would decide to delay injection back to the Earth are pretty scarce. I think we would, for all reasonable things that we can contemplate, attempt to go ahead with the burn as scheduled. And of course these burns can be handled by one man. The three men just make it that much easier. So we would, in all probability, go ahead.
No further questions. We'll adjourn.
Apollo 8, Houston. Apollo 8, this is Houston, over.
Go ahead, Houston, Apollo 8.
Roger, just want to let you know we still have voice contact, and we have the morning news for you. We can give it to you now or sometime later, your choice.
How about right now?
Very good. This is the 23rd of December edition of the Interstellar Times, a la Paul Haney, who would like to let you know there are only 2 more shopping days until Christmas. He says your TV transmission was a real big hit yesterday. Mickey Hershkowitz is doing double duty for the Post. He's written a couple of columns on your launch in addition to his other sports columns. And Jim, your mom certainly appreciated that birthday greeting.
This is Apollo Control, Houston.
21 convicts broke out of a prison in New Orleans yesterday.
At 49 hours, 18 minutes.
And President
We've
Johnson
just
went
tagged up
home
with the
last
crew,
night
and
from
Mike
Bethesda
Collins
Naval
is reading the
Hospital
morning edition of the
after his
Interstellar
bout with the
Times.
flu.
Here's how it's going.
He sent you guys a special message, not what to do for the flu, but congratulations on the flight. Are you reading me so far okay?
You're very clear, Mike.
Good. No, we had a big blizzard down here in the Midwest. I don't know if you could see that from up there or not. And in Houston, as a matter of fact, it's getting pretty chilly, about 35 degrees. And we'd like to know, who do you like next Sunday, Baltimore or Cleveland? Baltimore defense looked pretty tremendous yesterday. They put on a great pass rush, and it sounds to Capcom like Haney is trying to con you guys into a bet. Over.
I like Baltimore.
Are you giving points?
Negative. I don't bet.
I guess you don't if you don't give points.
Not with you, anyway.
Okay, that's about the size of the news. Houston, standing by.
How are the families doing, Mike?
Doing just great, Bill. Just talking to Valerie a few minutes ago.
That was Frank.
Oh, well, likewise with Susan. Haven't talked to her since last night.
Roger.
Apollo Control here. We got a little lull in the conversation. It may be resumed, and we'll take advantage of the lull to give you the altitude, which is 163,920 miles, and our velocity, 3,514 feet per second. If you take 3/4 of that, you can get the distance in miles per hour. I'd read that as something like 2,600 miles per hour. Colin.
Mike, this Frank.
We'll stand by. There's more conversation.
I got about 5 hours of good sleep last night.
Roger, thank you, Frank. We were wondering about that, about 5 hours of good sleep.
Right.
How's everything going up there, Frank? All three of you guys feeling okay this morning?
Feel fine. Jim went back to sleep. Bill and I are having breakfast. Everything seems fine.
Good, glad to hear.
This is Apollo Control here. Apparently we were wrapping up. The crew is now eating, and we doubt that we'll get any additional conversation for at least the next few minutes. The eat period extends up to 50 hours elapsed. We're at 49 hours, 29 minutes. The spacecraft, meanwhile, is about to complete its second. Well, let's back off that statement and put it this way. The Earth is about to complete its second revolution under the spacecraft. The spacecraft now, in relation to the Earth, is over Africa, and that is its second revolution since the second rev, when suddenly the spacecraft left the Earth out over the Central Pacific. Our flat map projection follows this trace, and it's running at about 10 degrees south latitude, very steady and coming back across. For map purposes, it appears that it's going from east to west across the face of the map. Of course, the spacecraft is quite steady, and the Earth is turning under it. At 49 hours, 30 minutes into the flight, this is Apollo Control, Houston.
Apollo 8, Houston, over.
Go ahead, Houston.
Just checking in with you after about a 45-minute quiet period. Say, we notice on your high-gain antenna, if you like, you can get a little bit more use out of it by switching to it from an Omni when you have a yaw angle of 90 degrees, 90, and a pitch angle of minus 45 degrees. We're noticing that you're staying maybe an extra 10 minutes on the Omni, which is fine, but you could get more use out of the high gain if you use that procedure, over.
Okay, thank you. It's a lot simpler for us as long as the Omnis are working. We got it all wrapped up here on the 8-ball, and when the rollbug points to an Omni number, we just switch it. It makes it a lot easier if it's not bothering you.
Okay, that's fine. Yeah, we're perfectly happy with the comm, Frank. We're just trying to be helpful.
Thank you very much. It's unusual that Mike Collins tries to be helpful, but nevertheless, thank you very much.
Aerospace first, Frank.
Say hello to Howard Kendall for us, will you? His procedure seemed to be working.
Sure will.
I hope you got everybody looking this thing over very carefully. One thing we want is a perfect spacecraft before we consider the LOI burn.
Apollo 8, Houston, we concur and we're doing that.
Okay. And Houston, Apollo 8, the water is in the process of being fluorinated at this time.
Roger, understand you're chlorinating the water at this time.
Roger.
Apollo 8, Houston, over.
Go ahead.
At your convenience, we'd like a readout of your service module RCS propellant quantities. We haven't gotten one of those so far this flight.
This is Apollo Control Houston here, 50 hours, 11 minutes into the flight. We have just established contact with Apollo 8, and here's how the conversation's going.
Houston, Apollo 8, on your read?
Go ahead, Apollo 8.
Okay, A. Service module A. You ready?
Ready to copy.
The temperature is about 111. The helium pressure, and you just want the quantity or you want the whole works?
Well, if you're reading, give us the whole work.
Okay, the helium pressure is about 37. The manifold is about 182, and the quantity is reading 80. B's got the temperature about 112, the helium pressure about 36.5, the fuel pressure 180, and the quantity about 77. C's got the temperature of 140. Incidentally, those other temperatures should have been 120 instead of 110. I was looking at the wrong calibration there. The pressure is 37. The manifold fuel pressure is about 182, and the quantity is 80. Temperature the package on D is 115. Pressure is 37. The manifold pressure is 181, and the quantity is about 83.
All right, Roger, Frank. I read you loud and clear. And on the temperatures, quad A and B should both be 120, Roger?
Roger.
Thank you.
I will trade all that good information for a readout of the actual quantities. If you give us a minute, we'll go ahead and plot them up, Mike.
Roger, we'll stand by. We'll get them for you. Apollo 8, Houston, I have your service module RCS quantities available, over.
Roger, we're ready to copy at 50 hours and 16 minutes.
Okay, I have them both in percent and in pounds. I'll give you both numbers. The pounds are slightly more accurate for plotting on your chart. Quad A, 72%, 219 pounds. Quad B, 76%, 233 pounds. Quad C, 70.
Whoa.
Okay.
Slow up. We just got quad A plotted. They're on separate charts.
Okay.
Okay for quad B.
Quad B, 76%, 233 pounds.
Okay, Quad C.
76%, 231 pounds.
Quad D.
76%, 229 pounds.
Okay. Would you give us the O2 and H2 as long as we're plotting?
Roger, stand by for O2 and H2. Apollo 8, Houston, we've got those numbers in percent. We're going to switch them over to pounds, and in the meantime, we're going to be changing our ground antenna in about another 2.5 minutes. You can expect a comm glitch, over.
Thank you.
Apollo 8, Houston, over.
Go ahead, Houston, Apollo 8.
Hi, Roger. I have your oxygen and hydrogen quantities when you're ready to copy.
We're ready.
Oxygen tank number 1, 270 pounds, 270. Oxygen tank 2, 267 pounds, over.
Roger, thank you.
Roger, on the hydrogen tank 1, 19.7. Hydrogen tank 2, 20.1, over.
Understand 19.7 and 20.1.
Roger, a little bit low on the line on your graph due to the fact they started off low. So.
Roger.
This is Apollo Control. We've apparently got a lull here in the conversation. We've been listening to the exchange between Mike Collins and Apollo 8 Live now for nearly a half an hour. Our present position in relation to Earth, 166,000 miles, 166,116 miles from Earth. Our velocity in feet per second, 3,466. And 1/4 of that would be about 2,725 miles per hour. Velocity will continue to slow down to a value of about 2,170 miles per hour, not feet per second. And at the point of lunar capture, or the point of lunar sphere of influence, which we are rapidly approaching, and we in fact reach, I believe, at 55 hours, we will begin to see a slight acceleration. I think the biggest unknown that we will experience today, we at least will be filling in numbers in an unknown but a predicted area, is in the range of temperatures that the spacecraft will be seeing. The Earth, even in Earth orbit, the Earth exerts a temperature factor over a spacecraft, even out at 100 or more miles. And the Moon, it's theorized, does the same thing because of its highly reflective qualities. But the area between the Earth and the Moon has no great reflector available, and thus a different temperature regime is experienced, and this will be of considerable interest to the spacecraft builders and the spacecraft thermal planners as we progress through this day. At 50 hours, 27 minutes, this is Apollo Control, Houston.
Houston, how do you read
Apollo 8, Houston, loud and clear. How me, over?
I'm clear. I'm just checking on you.
Roger.
This is Apollo Control Houston, 50 hours, 55 minutes into the flight. Mike Collins just put in I'll take that back. Apollo 8 gave us a call a few minutes ago, I guess to check and make sure our antennas are all switched around, which I believe they have been. We can expect some communication very shortly. We've had a number of calls on conversion charts, and we'd like to pass on to you a few of these conversion tables. Earlier we'd estimated that to get a handy grab on statute miles per hour, simply take 3/4 of feet per second. And,
Apollo 8,
of course, the number
Hour.
is somewhere between 3/4 and 2/3, so here are some more exacting
Roger,
tables.
Frank, your 51-hour
Before we
update
do
of
that,
block
let's go
data
now live to the
will be
communication.
omitted. The block data you have on board is satisfactory, over.
Understand, the block data we have on board is satisfactory.
Right, that's for the flyby and the paracynthian plus 2-hour block updates. We'd like also to get a current up-to-date report on all your windows. We're trying to make some alternate plans for using the center hatch window when you're in lunar orbit, and we'd like to make sure we understand exactly what the condition of all 5 windows is, over.
Okay, window number 1 and number 5 are clouded, but may be partially useful. The hatch window is very badly clouded. Windows 2 and 4 are good.
Okay, I understand the hatch window is unusable, 1 and 5 are partially usable, and the rendezvous windows are both good.
Right.
Okay.
Apollo Control here to take advantage of this lull to go ahead and give you this conversion tables that we talked about earlier. If you have feet per second and you want statute miles per hour, you convert by multiplying feet per second times 0.6818. The resultant number gives you statute miles per hour. If you want knots, you take feet per second and multiply by 0.5925. I repeat, feet per second times 0.5925 gives you knots per hour. If you want kilometers per hour, you take feet per second and multiply by 1.097. 1.097. And you get kilometers per hour. And one other factor to help, particularly our European, to help all reporters who are other than U.S., if you have statute miles per hour and multiply by 1.609, you can get kilometers per hour. So much for the lack of a universal numbering system. We'll go back and monitor the circuit now for any additional communication. Apollo Control here. Capcom Mike Collins is sitting back in his seat, and apparently we will not have any communication unless it's initiated by Apollo 8. So we'll take the line down now at 51 hours even into the flight, and we're 167,000 miles from Earth, moving at a velocity of 3,441 feet per second. This is Apollo Control Houston.
Apollo 8, Houston, over.
Go ahead, Houston, Apollo 8.
Roger, Frank. We'd like to ask you about the next few hours in the flight plan. We're inclined to let Jim go ahead and sleep and to slip the P-23 that occurs at 52:15. On the other hand, we think it would probably be a good idea if he returned more to the normal sleep-rest cycle, and if you got him up nominally to do the 52:15 work, then perhaps he'd be ready to go back to sleep at about 61 hours when he nominally is expected to do so.
Okay, he's up now eating. We're planning to go to normal procedures on the flight plan.
Okay, that's fine then. If it's not time critical that P-23 be done at 52:15, but if you're geared up to do it then, that's just fine.
Well, we thought we might give it a try.
Roger.
This sleep cycle here is, we're just going to have to real time it, I guess. I'm supposed to be asleep now, but obviously, or I'm supposed to go to sleep here shortly, but I just got up. We're going to have to kind of play this by ear.
Roger, understand.
Capcom flight.
Houston, Apollo 8.
Go ahead, Apollo 8.
Are the stars in the flight plan proper for this next exercise of P-23?
We'd like to talk to Jim about it when he's ready to copy.
He's ready.
Okay,
Good morning, Mike. How are you doing?
Fine, Jim. You're sounding good this morning. We'd like to give you a little rundown on these stars. As you can see in the flight plan, we've got you scheduled for number 33, Antares, number 34, Atria, and number 40, Old Altair. Now, the first of those, Antares, is in plane. The second two are out of plane. As you know, we like to get a mixture of the in and the out of plane. Antares, number 33, is close to the sun, and we expect that you're going to have difficulty getting those measurements on number 33. We'd like very much for you to try, but if you're unable to do number 33, then we propose that you use number 42, which is Peacock, to the lunar far horizon. We realize Peacock isn't the greatest one available, or greatest star in the sky, but it's about the only one available, over.
Roger, understand. Now, we'll go to Antares first and flash. You know, we tried it the last time, and I got one set before I lost the moon completely in the white haze. I'll give it another try. If it doesn't work out, we'll go to Peacock and give it
That's affirmative, Jim, and if neither Antares nor Peacock work, well then we just will be happy to go with Atria and with Altair. We'd like then to increase the number of sets and do 3 on Atria, that's 34, number 34, and 2 on Altair, number 40. But that's only in the event that you can get neither Antares nor Peacock. Apollo 8, Houston, did you copy?
Roger, this is 8, copied. We'll increase the number on number 34 to 3, and the number sets on 40 to 2 if we cannot get 33 or 42.
Yeah, that's exactly right.
This is Apollo Control, Houston, 51 hours, 41 minutes into the flight. And just a very few minutes ago, the wife of Bill Anders, Valerie Anders, joined us here in the control center. She's seated in the viewing area, which overlooks the mission operations control room. She's chatting with Mr. James C. Elms, the director of the Electronics Research Center in Boston. And Mr. Elms formerly was deputy director of this manned spacecraft center. With her also is Neil Armstrong, the backup command pilot for Apollo 8. This is the first of the wives to visit the control center during the mission. A little later today, we expect to see Jim Lovell's wife, Marilyn. And in the course of the past 20 to 25 minutes, we have backed up some conversation with Apollo 8. We're prepared to play it for you now. This is Apollo Control, Houston. That cleans up our backlog of tape at this point. One item on news conferencing for the next several shifts. We plan a news conference today, this afternoon at approximately 3:15 p.m. Houston time. That'll be 15 minutes after the change of shift for this afternoon. We will plan a news conference tonight at 11:15 at that shift break, and tomorrow morning at 9:30 a.m. All times are Central Standard Houston time. 3:15 this afternoon, 11:15, and 9:30 tomorrow morning. This, our distance right now, 168,829 miles. We should, we're to pass into the lunar sphere of influence at 55 hours, 38 minutes. About 4 hours from now. Over. And our velocity slowed down to 3,408 miles. And while we're talking, Mike Collins,
we're getting low bit rate from you now rather than high. And on this P23 work, for us to get our data, you're going to have to delay the DISCI display about 10 seconds when it comes up with noun 87. Over.
Roger.
Apollo 8, Houston, we're past that 87 display now. Did you write down what your trunnion bias was?
Negative. Houston, we haven't started 23 yet. Our cal is 0.
Roger, I understand. Thank you.
We're in the process now to go to P23 altitude.
Roger, thank you.
And this is Apollo Control, Houston. That apparently wraps it up for now. We're at 51 hours, 50 minutes into the flight.
Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Our downlink data shows that on star 33, Jim's using the lunar far horizon when he should be using the lunar near horizon. Over.
Okay, thank you. 220.
Roger, 220.
Let us check it.
Roger.
You want the far horizon now, Houston?
Roger, far horizon.
We have the far horizon in, Mike, at 220. I'll check again, though.
Yeah, that's right. We're requesting the lunar near horizon as per the flight plan. The lunar near horizon, we show that you are using the lunar far horizon.
Okay, Roger. I thought that you had copied up 220 to me. I'll put it in the near horizon.
Roger.
Apollo 8, over.
Apollo 8, Houston, go ahead.
Mike, it's getting kind of damp. We're getting a playback, Mike. It's getting kind of damp in here. Might be a good idea to go back into auto on the temp in, glycol temp in for a while to try to get some of this moisture out of the cabin.
Roger, stand by, Bill.
Roger.
Apollo 8, Houston.
Go ahead.
As we concur, we'd like you to go back to auto on the glycol temp inlet valve, over.
Okay, and what was our lowest radiator out temp during the last couple hours where we been in manual?
I'll get it for you.
And we're back in auto.
Roger, back in auto, and 29 degrees is as low as we've seen.
Okay, we're showing a cabin temp about 76. That's very comfortable, but we're getting a lot of condensation on the walls now.
Roger, understand.
Houston, Apollo 8.
Apollo 8, this is Houston.
Roger, Mike, while we're waiting for the spacecraft to maneuver to the moon, I might note that as we get closer to the moon, the light from the sun comes right into the scanning telescope, and it's impossible to use. You have to rely on the sextant alone.
Roger, Jim. Understand that light from the sun is coming into the scanning telescope, making it impossible to use, and you have to rely on the sextant alone. Can you attach any angle to that?
Well, Mike, I'm right now at the stellar point of 33, and I don't know where the sun is exactly from there, but that's about the angle. The optics are pointed right at the moon now.
Roger, understand.